and I am live. That is cool. Today is 26th of August. Shit, today is, my bad, 26th of September 2025, Friday. And Friday today is a special day because of Dracula. And that is all. Yes, let's just begin solving more questions in CP31 1500 rating. It will be nice, pretty nice. So, yep, this is going to be the next question. 25 CP31. I would need a stopwatch. And why is okay? Of course, Code Forces is slow. That is how it always is. And also, Mr. Mike. Shit, I forgot his surname. Mr. My bad. Shit, Mike Mirzayanov. Mirzayanov. Yes, Mike Mirzayanov, the founder from Code Forces. Mike Mirziano. He can do a lot of pull-ups, a lot of push-ups. That is very good. This is the next question. And for the last few questions, the problem statement has been very small. Okay. And the tests have been like a single test case is a single test. No T test cases. That has been nice. And now let's start Tmux set. Attach TCP. Yes. CD 1500 rating, CD 1500, start new Vim, and require spconfig framework is deprecated. Use Vim LSP config. Okay, I will fix that later. And there are updates in plugins. Okay, cool. Let's do this question. I will start the stopwatch and we will start solving the question. Okay, cool. The fair nut. Yes, nut. The fair nut found a string S. The string consists of lowercase Latin letters. The nut is okay, nut is a guy, is a curious guy. So he wants to find the number of strictly increasing sequences such that I, for each I in K in this, SPI, okay, the ith thing that we have considered is A, and for each except the last one in the sequence that we have chosen, there is such j between the current one and the next one so that sj is b. Okay, strictly increasing sequence. So everything is a and there has to be at least one b in the middle. The strings consist of lowercase Latin letters. The curious guy, so he wants. Wait, I can just divide the whole string whenever I see a b and the number of A's, just find the number of subsequences of size which only have A and multiply their count with each other. Yes, increasing subsequences these, and yes, the count plus 1 here. So 1 plus 1, that is 2. 2 into 3, that would be 6, but that is not the answer. Except the last one. So the first one can go with this and it can go with this. In the first example, there are these subsequences. Okay, I can choose them like as they are. Yeah. Okay, so I do have the ability to not choose any of them. So, okay, 1 into 2 plus 3. that would be the answer here. And here 4 into 0, 4 into 1 plus 4, that would be the answer here. And here we do not have a b. Here we do not have a b, and b is the only thing that we divide our sequence on. Okay, cool. Makes sense. Cool. Okay, yes, we can do this. This one makes sense. We got this. Hello, what are you doing? Can you explain a little bit? I just started learning web dev, HTML, and CSS, JS. So this is competitive programming, and in competitive programming, you get a bunch of questions, and there are like contests in competitive programming. Right here, this is a website, Code Forces, where you give these contests, and there is the next contest is on a 3rd of October. And in these contests, if you enter any one of the contest, you will see there are a bunch of questions. The first one, A, is the easiest, then the next one is a bit harder, then the next one is a bit harder. And according to your performance, you have a rating which goes up and down, like chess. In chess, when you play, two players play, according to their play, they lose or gain some rating. Right now, my rating is this much. And if I were to take part in a contest, my rating would go up or down depending on my performance. And the whole thing is to solve these questions. If there are two people and the first person has solved more number of questions, then he has performed better. But if there are two people who have solved the same number of questions, then depending on how much time did they take to solve these questions, their performance is judged. And the whole point is to get really good in at algorithms. Yes, get really good at algorithms and data structures, and just be able to see a question, look at a question, and solve it as fast as you can and as correctly as you can, and then submit it, and just do your best during a contest and increase your rating. So that is the point, and this is very stressful. During a contest, this thing is very stressful. And now we have this question that we have to solve. Okay, how is the input? Input is just a string, so string s, c in s, and depending on b. Okay, we need to find b, and okay, int answer equals 0, int a equals 0, for int I equals 0, I listen s dot size I plus plus. We will keep moving forward. So if the current one, if si equals a, then a plus plus, else if si equals b, then we have to evaluate our answer. Answer multiply by equals a. We will have two things, current a and just a count. Current a, multiply this by current a and ca plus plus, and current a plus plus, increase the total amount of a and the current number of a's, and else does not matter. Else, like literally the thing does not matter. Wait, okay, that does make sense, I think. And what if we saw no amounts of a? So ca has to be 1. No, ca will be 0. Here also ca will be 0. We will increment ca by 1, and answer we will multiply. If we haven't seen anything, so we cannot just multiply answer by this. Yep, we cannot just multiply answer by this because everything would become 0. Yep. Whenever we see a B, we have to see what the answer is. Nope, we do not have to see what the answer is. Answer is equal to 1. So if CA, if there has been some A, CA, then only multiply answer by CA. Yep. Yes, makes sense. If CA was something, only then multiply CA by answer, and that is cool. That is cool. And the same thing here. But if C equals 1, but if there is only one segment of A, then we will not multiply that by anything. Makes sense. That would be if answer equals A. So there is only one. A is the total amount of A's that we have seen, and answer is how many ways there are to choose these A's, and if there is only one segment which has A's, which has B on both the sides, or maybe not, but yeah, one B does not have A on both the sides. There is no such B which has A's on both the sides. Then answer should be equal to A. In which case, in which case, yeah, in which case we do not do anything. But if that is not the case, then we will do answer plus equals A. And at the end, output answer. And I hope a little typo. Okay, it just keeps on compiling. Okay, it is correct. In all the test cases, that is nice. Hey, are you only following CP31 sheet or anything else? CP31 for like solving code forces questions, and when I want to specifically do something, then there is the CSES sheet. This one, when I want to practice something specifically, like dynamic programming or graphs, which I want to practice next. Yes, graphs. And let's see, is this correct? Let me just submit this and I will read the chat. String s, taken s, answer 1 initially, yes, okay, CA equals 0, and the only edge case is that one. Is okay. Okay, I think this is correct. I want to get this right in the first try. Is this correct? String s, CNS, answer equals 1, CA, current amount of A and total number of A's. And if the current thing is A, then increment the number of A's. Else, if the current thing is not A, then if the current thing is B, that is the only concern that we have, multiply answer by CA. Yes, I think this is correct. And just in case, let's delete the whole code and rewrite it again. Reproducibility of code. Taken S, and after that we will have answer, which is initially equal to 0, initially equal to 1, and total number of A's, which is initially equal to 0, and current number of A's, which is initially equal to 1. Then we will traverse through the string I less than s dot size I plus plus if si equals a. If the current thing is a, then current number of A's plus plus and a plus plus. Else, if the current thing is a b, then what you will do is if current number of CA is something, then answer multiply by CA and CA equals 0. And if and yes, if CA, if there are some things current is, then answer multiply by equal to CA. And if answer equals A, that is there is just one segment of A which we can choose from. But if that is not the case, in that case, answer plus equals A and C out answer. Okay, cool. This does work. I hope this works on all the test cases. Let's see. And yes, I am a new subscriber. Hello, Gilbert. Hi, specialist. Intro is a specialist. I want to start competitive programming. Can you tell me a roadmap, brother? Yes, you would need two things. Okay, this is taking a lot of time. Shit. Okay, wrong answer on test case 6. I'm trying to think of what went wrong. And yes, okay, let me help you before that. So you need two things. You need theory and you need some okay, that is not theory. You need some theory and you need some practice questions. So for questions, you can go to this thing, CP31 sheet, and start solving questions from 800 rating and keep moving up. And for theory, you can go to this book, Competitive Programmers Handbook. And this PDF is like, you can just search CP Handbook. You will find it, the first link by cses.fi, fi as in Finland. And this is the book. And this PDF is inverted color, which is amazing because of this extension, dark reader extension. Yes, so this book for theory and this website for questions, and that is all you need. If you can do these two things, you can become a specialist, or you can become a candidate master even, I would say. You will be specialist today, right? Today is not a contest, right? The time is ticking, but okay. Today there is no contest now. Okay, for this one, I didn't give this Div 3 contest. Yep, welcome. Yes, the next contest that I will give is going to be on 3rd of October. Wait, there is a contest. No, I will not be giving this contest. Wait, this was yesterday. Yes, I didn't give this contest. I do not, from now on, I have decided to not give Division 3 contests because there are a lot of bad people in Division 3, right? There are a lot of bad people in Division 3 who use things such as this, and this is bad. But shit, why is my profile open in two tabs? That is very narcissistic. Okay, this is wrong. I think I should be more structured about this. Makes sense. I think okay, this makes total sense. Answer is 5. That makes sense. I have the choice of choosing this, and then I can choose this with 3 possible things to the right. Yes. 6. For this, I have two possibilities, and for this, I have three possibilities, and I add them. No, 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 no. Shit, is this like what we did yesterday? The day before yesterday, in a question in which we had to figure out about graphs. Yes, there was a question about graphs in which we had to figure out something, and either we had the choice to start, either we could start from zero and build our answer in a very complicated way. We could start from zero and keep adding things and get to the final answer, whatever it is. Shit, that was crazy. Or we could start from all the possibilities and keep reducing, cutting off stuff from this until we get to our correct answer. And can we use something like that here? So in total, I have 3. 3 factorial would be a very big number. Yes, 3 factorial. 3 into 2, 6. 6 minus 2. I can choose anything, but what I cannot choose is these two at the same time. And in how many ways am I choosing them? 2 factorial. That is also wrong. That is also wrong. And I do understand what the mistake is. I have a bunch of A's in a group, then B's, some B's, and then a bunch of A's, and then B's, and then A's. So let's say A1 is the number of A's I have here, A2, and then A3. I can choose any one of these, and then any one of these, and then any one of these. And what I'm doing is A1 into A2 into A3. That is something plus A1 plus A2 plus A3. So in this part, this is the number of ways in which I can choose 3 indices of A's. And this is the number of ways in which I can choose 1 index of A. And then there would also be a possibility in which I'm choosing one of these A's and one of these A's. That is just choosing 2 indices. And then there would be a possibility in which I'm choosing one of these A's and one of these A's. And then there would be a possibility in which I'm choosing one of these A's and one of these A's. And so I'm not considering 2. And that is inclusion, exclusion. Yes. Yes, this uses inclusion, exclusion, and I can use a list, a vector. String is CNS, and A's, yeah, A's, that is how you call it for what is N. N is nothing. And yo, everything is going cool. Sorry, problem F. It C equals 0. If Si equals A, then C plus plus, and else if Si equals B. Whenever I see B, we can add if C, then A dot push back C. So we have this. Now we have to work with this. Now we will have a vector of numbers like A1, A2, A3. These are a bunch of numbers which represent how many A's we have in different sections which we can divide. And now this is inclusion exclusion. But the thing is, this can be very big. Yes, for something like if the input string is like A, B, A, B, A, B, A, B, A, B, A. What is going to be the answer for this? Let's make it a little bit smaller. What is going to be the answer for this? There is only one way in which we can choose three A's, three indices of A's. There are one, two, three ways in which we can choose two indices of A's, and there are three ways in which we can choose one indices of A. So answer is going to be 7. And our vector for this thing would look like 1, 1, 1. And how do we get to answer of 1? To a answer of 7 from this thing? Yes, for this answer is going to be 7. I think 7, 7, 7. Right, 7. Yes, for the last one, I always have the choice to choose this or not choose this. So two choices. I have two choices for this. And for this one, I have two choices to choose this one or to not choose this one. So 2 into 2, 4. And then two choices for this to choose this one or to not choose this one. That is 6. But then the correct answer is 7. And yes, the correct answer is 7. A, 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 this A, and then this A, and this A, and then this A, and then A, A, A. The correct answer is 7. Why would it be 7? Okay, let me write down A, A, A. This is one answer. A, A. This is another answer. A, A. This is another answer. And then A, A, A. This is another answer. And then A, A, A. This is another answer. We have in total 1, 2, 3, 1, 2, 3, 1. 3 plus 3, 6, 7. 7 answers. Yes. There is something missing. There is something missing. And yes, all of these are valid answers. 4 into 2, 8. Yes, shit. Yes, 4 into 2, 8. -1. Okay, shit, I am so very stupid. My bad. Ah, shit. Okay, we don't need this. Long answer is shit. Answer is 1, and if C, just in case. So if C, then we can always first of all do A plus equals C. Okay, what even is that? A plus equals C, and if C, answer multiply equal to C plus 1, and then answer modulus 1E9 plus 7, and at the end there is just one possibility. No, there is no possibility. Yes, there is no possibility. Minus minus, and answer, if answer smaller than 0, then answer plus m plus equals m. What is the mistake? C. Okay, C is not declared, makes sense. Cool. This should be good. Should. And if this is still not good, then that is very bad. Code Fest 2026. You will be participating, right? What is Code Fest? Right. There is friendship going on. Uh, no, don't leave. Okay, we got past test 8, but I want to get this right. Okay, running on test 10. Mm-hmm. Okay. Uh-huh. I think this is correct. I might be proven wrong. Horribly wrong. Okay, still working. Okay, that is standing the test of time. Okay, shit. Okay, okay. This is very stressful because I don't even know if I should spend more time on my solution looking for mistakes. Is the algorithm slow? No, it is only going through the string once. So that is not slow. Okay, just give AC. Accepted would be nice. Okay, there are just tests. They never end. They do end. Okay. 32 minutes is a very long time for a question like this. 32 minutes is literally a long time for this. Let's say 33 minutes. And what is CodeFest 2025? Let's see. Uh, like ICPC CodeFest is ICPC competition. IICPC. Is that a typo or like Is that a bug or a feature? I for CP competitive program. I submitted a problem and it took 130 test cases. That is crazy. That is crazy. And I think most of those test cases come from hacking. Yes, like little test cases. IICPC. Ah, it is IICPC. They are sending invitation. This came 8 months ago. Codefest. We are thrilled to invite you to Codefest, a premier competitive programming event brought to you by IICPC. That is crazy. What is IICPC? There is no full form, but okay. Conducting premier programming competitions and fostering career growth in quantitative finance and software development. Okay, IICPC India. 20,000 total participants, 25 plus institutions, 12 plus number of partners, software. Okay, this is more for job, I think. Yeah, total price is 8 lakhs. Quant Fest. That is nice. Code Fest. Yeah, I guess not now. Hudson River, HRT, Jane Street, Jane Street, the Indeed contest. Jane Street, by the way, has like one of the best YouTube channels. Number file and computer file are by Jane Street, and that is crazy. 8 IITs. These IITs are also affiliated with this. Okay, I guess we can first study a lot and then go to the contests, and that would be nice. It is a competition. IICPC. 281 rank, that is nice. And yes, so what was the stupid thing in this? This is similar to if we go to competitive programmers handbook, like we can always find some reference of anything here. There is also bitmask DP here, but not in the dynamic programming chapter, but here bit manipulation, dynamic programming. There is bitmask DP, and shit, that is crazy. And if you go to number theory, primes and factors, this thing, number of factors, this is very similar to the formula I have used here. C plus 1 multiplied by total answer, and here also AI plus 1 multiplied by total answer. The same thing. At the end also do the same thing, and yeah, this works, this works. I think if I remove this line, sorry, if I remove this line, then this might fail a few test cases, and those would be the hacking test cases. Let's see. I think this will fail a few test cases. Okay, I want to rewrite the whole code again, by the way, just saying. Constant m 1e9 plus 7 and string s, cin s, and long answer equals 1, and int a, I don't need a, I think, yes, c equals 0 for int I equals 0, I less than n. What is n? N is nothing. S dot size I plus plus, and if s si equals a, then c plus plus, else if si equals b, then if c, then answer multiply by equal to c, and c equals 0, c plus 1, and c equals 0, and at the end if c, then answer multiply by c, and also whenever we do that, answer modulus with m. and then answer minus minus. And if I do not include this line, if answer is negative, because it could be negative, then do answer plus m. I think I am going to get a wrong answer if we remove this line. But let's see if we are getting the right answer with that line. No, we are not getting the right answer. Shit, we are not getting a right answer. What did I do wrong? Ah, C plus one. Okay, cool. If I remove this, I think we might get wrong answer on a few test cases. Let's see. That is just experimentation. Oh, didn't know that those channels were, yes, they are by Jane Street, and that is crazy. It says Jane Street on their banner. I hope I'm right. I think, yeah, by Jane Street. Supported by Jane Street, yeah, by Jane Street. That is pretty messed up. Uh, you will not solve yesterday contest. So will you not solve yesterday contest problem? I think you can solve all seven, but not that hard. Shit. Okay, so tomorrow, let's say, okay, tomorrow I will give a virtual contest then. I think that was the easiest of all the contests I gave till now. Can you talk like normal people? Shit, what do you mean by that? This is normal for me. And okay, I think I will give a virtual contest tomorrow for yesterday's contest, and that would be nice. And did I get a wrong answer? Okay, it is like, okay, there are a lot of test cases. Uh, yep, also that was, and I saw that you gave yesterday's contest and your rating went down by 22, even though you are saying yesterday's contest was the easiest among all the contests you have given till now. And that is why I do not like giving a Division 3 contests, because a lot of bad people participate in Division 3. And, and I think, wait, did your rating? No, shit. Okay, it is still analyzing. My bad. Shit. It is still analyzing. If I want to start, where I can start CP, by that you mean competitive programming CP. Yes, so when you want to start CP, you just need two things: somewhere to look up theory and somewhere to look up questions. For questions, you can go to this website, CP31 sheet, and start solving questions from 800 rating and keep moving up. And for theory, you can start reading from this book. And this is a very nice book. Whenever you see a topic that you do not understand, you can get a basic summary of that topic from this book, and then go on to YouTube or some other place if you do not understand, if the material in this book is not sufficient. But this is a very good book, and these starting chapters, I think you can just read as a normal book, just like in a chronological order. First read this chapter, then this, then this, then this, till I think till dynamic programming. You can just go through and read all of these chapters starting from the first one. So this book for theory, and CP sheet, CP31 for questions. And you can get this book just by go and search CP handbook and the first link by CACS.fi. This is the book, Competitive Programmers Handbook by Antti Laksonen, 2018 draft. That is it. Hi, I have been wanting to get started with competitive programming. I know C sharp well. I like hash maps and arrays, stacks. I know. I Okay, okay. I know some DS. Do you have any advice like how one should proceed? Yes, the same procedure. Just you need some place to for questions so that you do not have to just look up questions on your own. And this is a nice place, CP handbook, CP31 sheet. And for theory, this thing, competitive programmers handbook. And these two are enough to begin. And also, I would say these can get you to a very high rating also. Shit, okay, this is taking time. Okay, it is also accepted even without that one line. So that is cool. And now I can move on to the next question. Cut them all. This is the next question. So you draw. Yep. Next question. Okay. You are given a tree with n vertices. Your task, a tree. N vertices, a tree. Your task is to determine the maximum possible number of edges that can be removed in such a way that all the remaining connected components will have even size. All the remaining connecting Your task is to determine the maximum possible number of edges that can be removed in such a way that the remaining components will have even size. Even size. Even size. For maximum number of edges. Okay, and this is a tree. Okay, so whatever I can I cannot remove edges which connect a leaf to the tree because that would make the size 1 of that leaf because it is now not connected to anything. Therefore, answer in that case, I cannot do that. So if I have a leaf, if I have something like this, I cannot remove this edge because if I do remove this edge, then this thing is a singular component and this is not connected to anything and the size is 1, which is odd, so that is bad. And same for this because this is a leaf, this is a leaf. So for any leaf, I cannot remove that edge which is connecting the leaf. So, okay, in this case, answer would be 0. I cannot remove any edge, but in here, I cannot remove this. This is connecting a leaf. I cannot remove this. This is connecting a leaf, but I can remove this. So answer here would be 1. Okay, and how about this? I cannot remove anything. Answer is 0. And for a more complicated structure like this, these are nodes. We cannot remove this, cannot remove this, we cannot remove this, we cannot remove this. But can we remove this? We can only remove this. What if this was a bit longer, like this? Now we cannot remove this. Now we have the possibility of removing these two things. And among these, I cannot remove anyone because if I were to remove this, then here the size would be 2 and that is even. But here the size would be odd. 1, 2, 3, 4, 5. So here also the answer is 0. So the answer would also depend on n. If n is even, then it is easier to remove. But if n is odd, then it is not easier to remove. And if we have everything in a line, since these being edges, I cannot remove them. I can though remove this one. If I do remove this one, okay, let's say this is a candidate for removal. This is also a candidate, this is also a candidate, and this is also a candidate. And among these four candidates, I can remove this because on here size is 2 and here 1 2 3 4 5. Okay, so I cannot remove this. I cannot remove this. Nope, nope, nope. None of them could be removed, but because the total n is odd, this is odd. But if we had one more node here, I cannot remove this, and this thing is also now a candidate for removal. And if I do remove this part, this thing is even, and on the left everything is also even, so good. And I think when n is odd, the answer should always be 0. Here n is even, here n is odd, so -1. We cannot remove, yes. When n is odd, the answer is always -1. -1 represents we cannot remove any edge, so that makes sense. -1 is 0. Yeah, shit, my bad. Yes, it was not yesterday's contest. Hello. I started competitive programming in January and did consistently for 4 months, but my progress was not good. I was unable to come out of people, but my friends started late and still reached specialist. Help me. Uh, so you have to look. Okay, if you want to get better, then you have to like consciously deliberate practice is the thing that you need. And I cannot like just tell you what is wrong with your method of practice because I do not know how you practice, and that you would have to see on your own. But do keep in mind, for improving, you have to do deliberate practice in which you have to just decide what is the current thing that you want to practice, and have you, after doing a question, can you repeat that question? Can you write the code for it again multiple times on your own? And yes, deliberate practice. Just practice a lot. And yes, so boldly, in a like rule of thumb, you can say after doing every question, you should be able to reproduce the code. So if I delete this whole thing again, I cannot consider this question done unless I do have the ability to write the whole code again. And let me show you. Let me stop the timer here. And I do not. Okay, let's see if I can write the code again. And I equals 0, I less than n, I plus plus, and if si equals a, then c plus plus, else if si equals b, then if c, then answer multiply by equal to c plus 1. Remember that. And then answer, we need a modulus, for which we go here, const int m equals 1e9 plus 7. And here update c to be equal to 0, and do these two things again here, and then answer minus minus c out answer. Okay, okay, shit, I messed up with n. Okay, right. And therefore I can consider that last question, this one, fair nut string, done because I am able to reproduce the code. And I think that is one thing you can keep in mind, and it is hard to express this in words, so I had to show you. And yes, this is one thing that you have to keep in mind. And You do not have to focus on every single little thing. Just focusing on a few broad aspects of your practice can make you much better. So I would say just after completing a question, delete the whole code, write it again. That should significantly help you improve. I need to refactor my thinking and the way I practice. Yes. And you are the best person to find bugs in the way you practice and think. And let's start the timer again. Yes. So for this, so when n is odd, answer is always -1. But when n is even, then we need to see what is the maximum number of things I can remove. And that is it easy? I mean, everything is connected. So I just need to find the leaves. Yes, I just need to find the leaves. And whenever I see a leaf, I cannot remove this one, but I can remove this one. That is good because this is even. Yes, this component would be even and this component would be even. And if I can remove this, so I will greedily speaking, remove this one. And now this thing is what I have to work with. And here, now this one is the new leaf and I can remove this. Hmm. Hmm. So I need to quickly find out how many leaves there are, even after removing some things. And that can be done if I start with saying every node from 1 to n is a leaf and have a data structure called leaf of size n, right? And for leaf I would be 1 if I is leaf, and initially everything would be 1. And what I will do is like normal way to represent a graph, matrix list representation. So I will have a matrix list which would represent how these nodes are connected to each other. And if I see whenever I'm adding a node for one node, I will see if the size of that thing, if it becomes 2 or greater than 2, then I will turn leaf I for that thing equal to 0, right? And so initially I will have a list of all the leaves, or maybe I can use a set so that I can quickly fetch and yeah, so I can quickly see things. So instead of this, a set would be better. Unordered set or ordered set, it does not matter. It would be better. And a, a queue, a queue would also work, right? So after removing this thing, I know what this leaf is connected to. And shit, what if, what if, which one do we cut? Shit. If we have something like this, what do we cut? And this looks like the flag of the world government in one piece. Yes, it awfully looks like this. And so yes, we identify this thing as a leaf. So after that, what do we cut? Do we cut this? Yes, we will cut. So we know that we have to cut something which is connected to this part, and we'll see everything that is connected to this. And we have to make sure that this component is even. The size of this component when we make a cut is even because every cut is going to make a component. So we have to make sure two things, that the size of this component is even and that And also we are not cutting a yeah, if we can just make sure that, then to make sure that the size is even, let's say this thing here is connected to 4 different things. And yep, if these are leaves, among these 4, this one is a leaf, this one is a leaf, this one is a leaf. And then I have a choice of cutting other things which are not a leaf. Here, this one is not a leaf. This one is not a leaf. So can I just cut it? No, exactly. Here the total n is even, but if this node were here, then I will see that, okay, this is a leaf. This leaf is connected to this node, and this node is connected to this leaf, and this is a leaf, so I cannot cut this edge. I cannot cut this edge because this is a leaf. I can cut this edge, but if I do cut this, the size of this component is odd because it is 3, and that is bad. So I cannot cut this. So yes, what if we had something like this? We know for sure we cannot cut this edge. We cannot cut this edge. Can we cut this? It would depend on how many things are here. And can we get this? It would also depend on how many things are here. So I think the approach is wrong. The approach itself is wrong. Yep. This is a tree. Yes. Okay, I have edges, right? I can, I have a bunch of edges and I can always eliminate these edges which are connected to a leaf. So this is a leaf edge, this is a leaf edge, this is a leaf edge. So I cannot just cut them. So I know that for sure. And now this is a candidate, this is a candidate, and this is a candidate to be cut. And which one do I cut? I can cut this one, that is for sure. I can cut this one. And all of these cuts are independent of each other. Yes, because if I do cut this, then the number of nodes that go away, which literally did go away somehow, was even. And it should not have any effect on the parity of this component. So that is nice. And I can cut this edge, and that is nice. So for every edge, should, and cutting these edges is independent. That is one thing. So for every edge, if I can just figure out how many things are to the left of that, how many things are to the right of that edge, it would be nice. It would be nice, really. Yes, all of these cuts are independent of each other, and that would be the answer. I'm trying to think of a DFS algorithm which can help us. in this, since the cuts, uh, all I need to know is for every edge, how many nodes are there to the left of it and how many to the right. Winston Quarterly. Hello, Mr. Winston Churchill. That is crazy, this thing. Okay, we just need to figure out a fast way which I can use to see how many nodes are to the left of a edge and how many are to the right of a edge in a tree. We can make something more beautiful than this. That is one piece. For a complicated tree like this, for every edge, BFS, DFS, we can use a dynamic programming approach for that to figure that out. How many things are to the left or to the right of a edge. I know for this edge on the left, I have one thing. Let's label them. One edge, edge 2, 3, 4, 5, 6, 7, 8, 9, 10. For this edge, on the right, we have 1 and on the left, we have to calculate. And that is messed up. Shit. So for this edge on the left, I have to see how many things is this edge connected to on the left, and if there were some other edges, how many things are they connected to on the other side, and add all of them up, and that would be the answer for this. And this is that would work, but it just feels like that is over engineering. There has to be a simple thing because I do not need that much information. I just need to know the parity. That is literally too much information, and we do not need that. There has to be a simple thing which we can do. All we need to know is the parity of an edge. Okay, by default, by the way, we know the parity of all of these edges which connect a leaf, right? We can easily figure out in matrix list representation which edges which edges connect a leaf, and for them the parity on one side is 1 and on the other side is n minus 1, n minus 1 nodes on the other side, and on one side they are connected to only one node, so the parity is odd. And same for this, same for this. And all we need is the parity. I think we can use some sort of DFS here. Yes, I think we can use some sort of DFS. But that just seems like over engineering. But there is no other thing that is coming to my mind. So we can start from leaf. No, we do not have to start from leaf. We have to start from a edge and not a node, because for a edge we can in some manner have sort of left and right, but for a node we cannot, because a singular node can be connected to multiple things. We cannot have left, right, or anything for a node. Mm, yes, we cannot have that. Is there some invariance? Okay, first of all, we are checking if the total number of nodes is odd. Okay, the total number of nodes has to be even. If it is odd, then answer is -1, because we can never divide the graph. Hello, what is the problem? Problem is this one. Cut them all. I think there has to be an invariance. That is, if n is even, and if I, let's say, have a node and I have its degree is something, and so there is a odd number of nodes that this thing is connected to. In total, they are odd. Okay. If the degree is, let's say, 1, if the degree is 1, then I know for sure that this component has a parity of odd parity. The number of nodes in this have odd parity, and this one is like, of course, odd because there is only single node. But if the degree is 2, I have one thing here, right? And since the total sum is even, then one of these has to be able to be cut, because one of these has to have a parity of one of these components. If I cut them, has to have a even number of nodes, and the other one has to have a odd number of nodes. That is, the parity has to be reversed, because there is a reason, because since this thing is 1 and the total sum is even, so if both of these components, this one and this one, if they both had even number of nodes, then their sum would be even, and adding 1 to a even number gives odd, and that is wrong. And if both were odd, that is still wrong. But if one was odd and the other was even, we add this one to the odd component and we get an even number, and we add that even number to the number of nodes in the other component, and the total sum n is reserved. That is even. The question is, are we going to double count? Because this thing is going to be connected to something. And will we count this edge again? Let's go for higher degree. When the degree is 3 and we have one thing here, n is even. So one of these, now there is ambiguity. One of these has to be odd, that we know for sure, so that this total sum is even, and when this is even, these two can have any parity, and it has to be same, even or odd, so that their total sum is always even, so that n is even at the end, and that is ambiguity, and the degree can be much higher than this. Yep, much higher. I think a DFS approach, it might be over engineered, but this is the only thing. Where did you learn basic C++, problem solving basics? Okay, for there are two questions, C++ and basic problem solving. For problem solving, I started from this thing, CP31, 800 rated questions. These questions are easier, and you can start from this for questions for problem solving logic. And if this might feel a bit too much overhead, so I would suggest instead of this, you can go with Advent of Code. This is a nice website. You can go here. Let me log in. GitHub. I think there is. Okay, I got in. That is nice. Yes, you can go to this website for problem solving skills, and the way that problems are presented on this website is pretty intuitive and pretty nice. And all you have to do is figure out the answer for the problem, and there is a input box at the end, and you have to input the answer, what, not the code, but the answer, numerical or maybe some other thing, whatever the answer is, you have to submit it. And here there is the input on which you have to run your program, figure out what the answer is, and input the answer here. And this thing is more intuitive, I think, compared to code forces questions. And you can do a few questions here to get a kind of kick, and then you can move on to CP31, the real thing. That is what I would suggest. And for basic C++, C++ is a very complicated language, and if it is your first language, then it is going to be hard. But if it is not your first language, then you can start C++ from this website, learn X in Y minutes, go to C++. Here is a primer on C++. You can go through this thing, and that is pretty nice. You can start C++ from here if you are not a beginner. Of Advent of Code, it is just adventofcode.com. And for this website, if you are a beginner, then this is going to be very hard. C++ itself, no matter where you are learning from, is going to be very hard if you are new to programming. So I would suggest first you should learn C and then move on to C++. C. And yeah, if you are a beginner, then this website is not very good for you, because this website assumes that you know what programming is. And yeah, this would not be a really big help for you. So before starting with C++, you should start with C and then go on to C++, because you might get very scared. C++ is complicated and hard. And yeah, so take your time with C and then move on to C++. And next question. And also Dracula. Just it will just like be there. What can we do? So DFS seems to be the approach here, because I can Yes, all I need to figure out is a way. All I need to find is how many of these edges have even number of things on one side, just on one side. If they have, yes, that is all I need, even number of things on one side. Adjacent edges. I think I should use some other representation than this one, which might be more helpful for going from one edge to another edge. From this edge, I mean, from this node, we can go to this node, and then from this node, we can go to any of the other nodes. But we are talking in terms of edges. Yes, we are talking in terms of edges. If we do BFS, starting from all the leaves, if we do BFS starting from all the leaves, shit, okay. Where is a nice graph? This is a tree. This is a tree, a very big tree. Okay, and if we do BFS and in our queue we add all the leaves, there are a lot of leaves in this one. These are all the leaves which have been added in our queue. Then we can always mark these edges as no, we cannot cut these because they break our rules. And after that, if we cannot cut this, then what are the other things that I can add into the edge? Boom, no. We can add this, we can add this, we can add this one, this one. And since I know the degree, the depth that we are at, no, we will have a visited, a vector called visited, which will have all the visited I would be true if we have visited I. So that is something. What even is the algorithm that we can use here? BFS, DFS. DFS is not going to work. No, because we just do not want to go through a simple path. We need to know every other thing that is connected to that. A BFS. This answer is no. Then for this, and this. We don't know the next things. We just need a way to find out how many things is a edge connected to on one side and how many on the other side. That is all. Wait, if something is not leaf, can wait, if something is not leaf, can I always cut it? This thing is leaf. No, don't cut this, don't cut this. This is not a leaf, and here I can literally cut this one. But here I cannot, yes, I cannot cut this one because there will be three components, three things, and that is odd. So yes, we cannot always just do that. We cannot cut this, we cannot cut this, we cannot cut this, but this we can cut because this component has even number of things here. And wait, what is the n here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is wrong. But even if I add another node here, we still cannot cut this one. That is bad. That is literally very bad shit. It's just, I think there could be a graph algorithm which we can use to figure this out because I haven't read a lot of things about graphs, so that is why I think I'm having difficulty in solving this one. I have to work on graphs. Yes. In the competitive programmer's handbook, there is a whole like section on graphs, graph algorithms. I have gone through basics of graphs and graph traversal, but there is shortest path, tree algorithms. Wait, I think we can use some of the tree algorithms here. Maybe tree traversal, diameter of a tree. I don't know. Kruskal's algorithm, union find structure, directed graph, topological sorting, tree queries, finding ancestors, subtrees and paths, lowest common ancestor, offline algorithms is something. This might actually be something finding ancestors. Let ancestor xk, subtree paths. A tree traversal array contains the nodes of a rooted tree in order depth. I think in this question, we need to know something about trees which we do not know, and thus the difficulty. And it would be better to just go through and read the editorial. We are going to read the editorial, and we do not have to feel bad about reading the editorial. It is not always bad because we will not be able to solve every question, and we do not have to like invent all the algorithms that we use. Note that if there is an edge that can be removed, we can do it without any problem. Yes, we noticed that much. Let's consider such edge that one of the obtained subtrees, it is impossible to, let's consider such edge that in one of the obtained subtree, it is impossible to delete more anything else, and its removal is possible. Okay, we cannot remove anything else, and it's that particular edge which is under consideration, we can remove it. What happens if we delete it in the tree to relative to the other edge end of the tree? The odd even balance of the subtree is not changed, which means that the edge has not been affected by further deletions. Yes, odd even balance is not changed, which means if we remove it, the answer will be better. So we can use a greedy algorithm. This is followed by a greedy solution. In DFS, we count the size of subtrees for each vertex. In DFS, for each vertex, this vertex is connected to a bunch of things. Let's say, what is the size of this subtree? Can I cut it? If I can, okay, what is the size of this subtree? Can I cut it? If yes, then okay. What is the size of this? What is shit? I can use that. And shit, I can just use DFS, basic DFS. This didn't require anything else. Shit, shit. This was okay. Let's write this. Let's write the solution for this one. From where can we download the CP handbook sheet? Okay, you can just search CP handbook, and by sheet I am supposing you mean this PDF, and this is the one. Just look up CP handbook and click on the first link. That is it. CP handbook, competitive programmers handbook. And how do we have the inputs? We have them like this. N and vector of integers, ADJ as an adjacency list, and there are going to be n+1 nodes, and each thing would be empty initially speaking. For int I equals 0, I less than n minus 1, I plus. Okay, my shift is not working at times. Int L and R, and then C in L, C in R, and ADJ L dot push back R, say that R is connected to L, and say that L is connected to R. Push back L. And here we will have const int range equals, what is the range? Maximum possible range, 10 power 5, let's say 1e5 plus 1, and we will have a bit set of size range called visited, and then we will have a DFS algorithm, and also int answer equals 0. In DFS, it will take in I, the current node, and a vector of vector a reference ADJ at this length, and yes, no, this will return the size of subtrees. Yes, the size of subtrees. And how would I know the size of subtrees? Hmm. Calculating the size of a subtree. If I want to calculate the size of a subtree, like if things are connected like this, I want to calculate the size of this subtree. So I call DFS on this and put this edge as visited, this node as visited. So I will not come back here. And then yes, for this I calculate the size of this subtree, calculate the size of this subtree, and add 1 to it, and return that number. And also, since I know the size of this subtree and the size of this subtree, I can say I can add this edge or maybe this edge as one of the answer. If I can cut it, I will increment the answer. That is nice. C equals 0, sz size, and again return sz plus 1. And here we will have for int x in adj I. That is every node that is connected to the ith node if not visited x. If x has not been visited, then what we will do is int size or sz x equals dfs, called dfs on x with adj, and also put visited x equals true. Now if this thing is even, zx and with 1, if this thing is even, then answer plus plus, and whatever it is, size plus equals szx, and at the end return that size. Okay, and what we will have here is answer we will call szx equals, or size 1 equals, we will call dfs on the 1 node with adj, and if this thing sz1 is, hey, what does that even mean? Wait, shit, what is this thing even going to return? We don't need what it is going to return. Shit, we just call the function. Because node things are happening with this and not with that. Yeah, cool, cool. This is going to get the job done. See how answer. Hopefully. Or maybe not. Shit. It says 2 here. It says, yeah, depending on the parity of n. If n is odd, then see out -1. My keyboard is acting very wonky. 5. Why do I say 1? Yes, because, yes, makes sense. Visited 1 equals true. Okay, cool. That seems to work. That seems to work. Hopefully, it is working. That is cool. So, what we will do now is we will remove the whole code and rewrite the whole thing from scratch. That is how you make sure that you know the thing, that you are not just pretending to know the thing. Int n, take in the number of nodes, and then we need to store all the thing vector int adj size n plus 1 and vector n initialize. Yes, now we will take in all the edges L R for int I equals 0, I less than n minus 1, I plus plus C in L and R, and then we will push back into ADJ dot push back R and ADJ R dot push back L. Now we have stored the whole data and we need a few things. Const in range equals 1e9 1e5 plus 1. That is the maximum number of nodes that we can have, and we will have a bit set of size range called visited, which will say 1 for I if we have visited the ith node. And then we will have a DFS algorithm. It will take in index and a vector of a vector of integers, a reference to such a thing called ADJ. And what we will have is int c or size initially is going to be equal to 0 for this sub graph, and then for int x, for every x node which is connected to the current node I, we'll see if not visited. If x hasn't been visited, then we will put x as visited x equals true, and you will get the size of this subtree x, which is going to be DFS. We will call DFS on x with ADJ as the other argument, and if the size of this subtree is even, then answer plus plus. And what is answer? Answer is a global variable, int answer initially equals 0. And whatever the case, we will add this to the size plus sz x, and at the end return size plus 1. Why plus 1? Why plus 1? Because we have the size of all the subtrees which are connected to this current node, plus this current node itself is also a part of the subtree which starts from this current node. That is nice. And here we can put visited 1 equals true and call DFS on 1 with ADJ, adjacency matrix, adjacency list, or yeah, adjacency list is the nice name. And then at the end, see out answer. Okay, yes, we also have to check for n. If n is odd, then see out -1 with a new line. Everything is happy now. That is cool. Yes. Shit, the name is in Cyrillic. Submit, and let's see how we go forward. This should work. But yeah, this does not make sense. It took me 56 minutes plus reading the editorial to solve this one. If I got this right, if that is a big if we got this right, this is bad because this took us a long time, and that is not good. Even though this is 1500 rated, that does not change the fact that this question took longer than it should have. This question does not deserve this much time. This question does not deserve this much time. I think It is because I personally do not have a lot of experience working with graphs, which is an indication that I should change that. And yes, soon enough, in a few days, I will do some streams on graphs, in which we will, first of all, go through a couple of chapters in Competitive Programmer's Handbook about graphs, I think. Yes, so I won't go through these chapters on stream because these are very basic chapters. We can go through, I don't think we do need Bellman Ford, Dijkstra's algorithm, and Floyd Warshall just now. We should go through trees. That is nice. Trees is nice. Then directed graphs. That is also something that we have to go through. And tree queries. That is something we can go through. Then this thing also, paths and circuits. Full cursor. And then flows and cuts. With these, this also. Okay, so we will have 1, 2, 3, 4, 5 chapters that we'll go through on stream, and that is going to be nice. And after going through them, we will, okay, accepted, that is nice. We will go to the CSES website and do some graph questions. These. This is going to be nice. I've done a few on my own before, offline, but then we will do graph questions. And what is this monster question? I wasn't able to do this somehow. You and some monsters are in a labyrinth. Ah, yes, I do remember. I do remember. I think I'm only getting wrong answer on one submission here. No, maybe more than one. Yes, this one. A wrong answer on just a single test case, and that is crazy, which is the third last test case. And I think the answer is off by one. No, the answer is off by a bit, and that is crazy. Yes. 59 minutes for this question, which is very bad. 59 minutes is not a like good thing. 59 minutes is not good. Nope, not even close to good. 59 minutes is a long time. And this is just telling me that I have to do a lot of graph questions. We are almost at the end of this 1500 list. There are 2 questions left. I will do them at some point, but we only have about 5 questions. That is nice. And before moving on, I just want to look at this once more and try to see why did it took us this long. This question does not deserve 59 minutes. 59 minutes is a very long time for this. 59 minutes. Nah, 59 minutes is bad for this question. Nah, 59 minutes is bad for a simple question like this. Anyways, yes, this is just why I think the reason that I would give why it took me 59 minutes is because I do not have a lot of experience working with graphs. That is the only thing. And the thing that I can take away from this question is I have to do more questions which involve graphs. Shit, is this a graph question? I don't know. It would be crazy though. Let's start doing another question. You are given a sequence A1 to AN of one-dimensional segments numbered from 1 to n. Your task is to find 2 distinct indices I and j of one-dimensional segments numbered from 1 to n. 2 distinct indices such that segment AI lies within segment AJ. How segment you are given a sequence AI of one-dimensional segments. So how do I know where do they start and where do they end? This segment lies. Okay, your task is to find two distinct indices I and j, and they are inside each other if this thing is true. L2 is smaller and R2 is bigger or equal. Okay, this is easy. And okay, if the answer is possible, then return I and j starting from 1. And if not possible, then return -1 -1 for both. This is easy. I can use sort. Let's see, speedrun. And then vector of pair of integers. Seg size is going to be n. Initialize the pairs like this. And for int I equals 0, I less than n, I plus plus, cn seg I dot first into seg I dot second, and then sort seg dot begin and seg dot end. And we need a like a lambda function here, not int, but auto, let's say x and auto y, and these two are pairs. So if x is not if x is not equal to this thing, I first, yeah, so sort them in ascending order of their starting points and in the descending order of their ending points. So if x dot first is not equal to y dot first, then return x dot first is smaller than y dot first. Else, if that is not the case, then return x dot second greater. Keep in mind greater, because we want to sort them according to in descending order of their ending point. Y dot second, and after that, so that would be easy, the furthest ending point that we have. Okay, for int I equals 0, I less than n, I plus plus. For this current segment, what are the candidates? Okay, we will keep moving forward until we find a thing. We will not go till the last one. And the best possible answer, could it always be the next one? Nope. Completely inside. If I sort them in ascending order of both their starting and ending point, or not sort them at all and have a map in which the key is their starting point and the value is their ending point. That is one thing I can do. Okay, if the next if the next thing has the same index, has the same starting point as this one, then we have two indices which are I and j, and x comma y, and initially x equal to y equals -1. See out x space y with a new line. And this is the question that we are doing right now. Hello. So we will never go to the next point. But any one of them could have the thing here. Yeah. Segments. We have to find segments which are within each other. Plots within plots. Segments within segments. Not even touching borders. These are not even touching borders. A segment starts from 1, goes till 10. 1 and 2, obviously, the answer. 3 and 4 could also be answered. In the first example, the following pairs are considered correct. Match exactly the following pairs: 2 and 1, not even touching borders, 3 1, 4 1, and 5 1. Yeah, 2 1, 3 1, 4 1, 5 1. They are correct, and these things touch one border. These two, and I think 3 and 4 is not correct. Yes, 3 and 4 is not here anywhere. So that is because that is incorrect. Segments which lie within each other. But how? Yes, time complexity can be very big for n square. Yes, n, what is the maximum value of n? N can be big. N can be big. Okay, so the one which has its, if I am currently at the ith pair, then the one whose starting point lies at the ending point of the current segment or to the right of the ending point of the current segment, that is obviously not a candidate to be a valid answer. So do I actually have to go through all the segments which are possibly a correct answer? I think not. I should have the ability to find out segments based on their ending point. I have them sorted according to their starting point, but can I sort them according to their ending point also? Or the length? I can sort them according to their length. No, Yes, according to their length. Take the biggest segment first and then the smallest, then the smaller ones. Like they're starting, sort them first according to their starting points. Sort them first according to their lengths and then sort them according to their starting points. Right? No, nope. There is the same problem again. This seemed simple, but it is not very simple. Initially, it did seem simple. But certainly it is not simple. Okay. Mm, so I have a thing like this. Number line, I have some segments like this. Yep, a bunch of segments. And I need to figure out, is there a segment which comes completely within another segment? And if I start iterating through these according to their starting point, wait, I did do a question like this before. There was a question like this somewhere. And it was pretty, I think that question was more complicated than this one. Yep, that question was more complicated than this one. This is supposed to be easier than that one. Okay, we start from this. Then we need to see which end points. Okay, I can have two copies of the same thing, I think. Two copies of the same thing. In one, everything is sorted. How many segments are within each other? I start this number of segments that I am in goes up by 1. I start another segment, number of segments goes up by 1. I start another segment, number of segments goes up by 1. Because of this, goes down. Yes, because of this, goes down. But then, because of this, goes up and goes down. But this going up and down are of different segments. I need to know which segment went up or which segment went down. Which segments are within each other. Okay, let's say I am looking for this segment and I need to figure out the starting point has to be inside and the ending point also has to be inside. Wait, if I do have, I think if you have a map, no, shit, I need to return the index. So I cannot just blindly sort this thing. Shit, I need to return the index at the end. I cannot blindly sort this. That is bad. But it will require some sort of sorting. So I can use sorting using iota function. But then how do I figure out which segments are within each other? This segment is small and this is within this one. But how do I know that? We can start from this starting segment, then this starting segment. Mm, yes, and we can maybe keep a set, a stack. Keep a stack. Okay, let's number these 1, 2, 3, 4. If I have a stack and we start with this, we'll put 1 here. Then we started going through this segment, so we put 2 here, and then we started going through the third segment. All right, then we put 3 here, and then we see 1 is being exited, and that is not at the top. So cut. Yep. So 1 is not a valid answer anymore. But we could have had something like this, in which we would, let's say this is 5th, and we would add 5, then we would add 4, then we would remove 5, then we would remove 4, even though these two are valid answers. Yep. Wait, shit, if we do not remove anything, if whenever we are removing something and that thing is not from the bottom, if we are not removing something from the bottom but somewhere up, then that and this thing are the answer. Then that and this thing are the answer, right? Because we are inside this segment and we are removing this segment. So this segment and also this segment started after this segment, right? This segment is started after this segment and it is being removed after before this segment or maybe at the same time. So these are the answer, and what you have to do is sort the whole segment thing using iota. Okay, makes sense. But int ii size n and iota ii dot begin and I dot end, fill everything starting from 0. Cool. And here use II. Here also use II. And here we will have 1 and 2. Yes. Here we can say let's have 2 integers, int I and int j. And we will have pair int parent x equals parent x equals seg I and y equals seg j. And then we compare and give out our thing. And now we need a stack or something similar. Or instead of a stack, we can use a vector with 2 pointers, which one pointer pointing to the bottom of the stack and one pointer pointing to the top of the stack. And this stack will never go this like higher pointer, the top of the stack will never go higher than n, because that is the maximum number of things that we have. And that is cool. Okay. Let's have our vector int stack size n, and bottom or b equals 0, and top also equals 0. And top is the place where we are going to add the next thing, and bottom is the place where something is added. Okay, bottom is like the bottom of the stack. And we can initialize our stack 0 is seg I seg I seg shit, this is messed up. How can we go through things like this? I can only go through their starting points, but how do I know the ending points whenever I do encounter a ending point? That is crazy shit. Yes. I do have a n square time algorithm, but it is like n square, so it is not good. N square time is, of course, not good. N time algorithm, constant or linear time algorithm, or log n time algorithm would be very much preferred. For a certain segment, I need to go through all the segments, which is I need to see, are there any segments who have their starting point either here or like to the left of the writing of the ending point, and 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 a segment which has their ending point at the right end or to 1 plus the starting point of this segment in question. And if we can do that in log n time, it would be preferable. It would be acceptable. Nope, 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 nope. This seems to be a simple question, but no. Segments within each other. Segments have to be within each other. That is the only requirement. The segments have to be within each other. That is the only requirement. Segments have to be within each other, so their starting and ending point. Mhm. Segments have to be within each other. If we go with one of the examples, this one, or we can go with this one. This one is nice. If we label things, and this can be negative. No indices, they will not be negative. If we say 1, 2, 3, 4, 5, 6, and then let's say 20 after some point. Then here we have three segments, 1 to 5, then 2 to 6, and then 6 to 20. And there is like no other segment is within any other segment. No segment is within any other segment. And this should also depend on the length. So I should be able to index segments of the same length or whose length is higher. Wait, think I think we can do this. Uh, we can sort them in two ways. First of all, depending on their starting point, and then depending on their ending point. First of all, depending on their starting point, we can have a vector in which the segments would be stored as a pair, as pairs of numbers, and second, according to their length in a simple vector of integers. So I guess I'm just thinking too much here, over engineering the answer. Segments within each other. And I do remember there was a question which was very similar to this one. Zero array, count subrectangles, max k complete words, balanced bit string, k amazing numbers, combat, tower, line empire, I think was a good one, if I remember correctly. Yes, I submitted three different versions of this. Okay, this does happen. This does happen. Sometimes you just cannot solve a question. Like the brain does not work properly. And I think now I have a few choices, either to just go grind and sit here for another hour or two, more than an hour, and see if I can do more questions, or I can take a walk and then get back to studying. Yeah, studying is something that I would like. So okay, I will be ending the stream now because I think, yeah, this does not feel like a right time to solve questions. And I think I'm not making excuses because, yes, because my brain doesn't feel, uh, it doesn't feel like my brain is in the mood is not the right word, in the correct phase for solving questions. That is one thing, but instead, what I can do is do something which my brain is more familiar with, or my brain is more able to do, and that is read some things. And yes, I have to read some things, and also I have to watch a video on Bitmask DP by Algorithms Live. Bitmask DP by Algorithms Live, this video. Not this one. Yeah, so I guess that is what I will do, and I will be ending the stream for today. Yeah, today the stream is short, and I hope I'm not making an excuse by cutting short today's stream. And okay, yes, that would be the end of today's stream, and thank you for being here. Bye.